Okay. Parallel computing is the one of the subject for your semester, which is having the BCS702 as the subject code here. We have the same as 5 modules here. One among that one, we have to take the one module. For the first module, we have the 2 questions, and also for the 5 modules, we have the 10 questions. We have to answer the among one module. We have to answer only one. Okay. And also first module we have the introduction to parallel programming, and here we will be studying the how the parallel hardware and software and also program parallelly how they are organized. Okay, how the auxiliaries, and also we will be studying the SIMD means what here, single instruction multiple data and also multiple input, multiple instruction multiple data will be studying, and also interconnection of networks. Okay, interconnection of networks, and also cache coherence. Okay, as you already know the cache, what is the cache and all coherence we will be studying, and also shared memory and distributed memory in the okay, in the CO, okay, DDCO, digital design and computer organization, there we have studied the some cache memory and also shared memory and distributed memory. Same concept is here with the different diagram. Okay, nothing. Okay, and also we'll be studying the coordinating between the processor or threads, how they are coordinating each other. Okay, one thing you remember, this is the parallel computing is the advanced. Okay, it's the extension version of the CO. Okay, extension versions of the CO. Okay, you have studied no CO, computer organization there, no, digital design computer organization. Okay, in the CO you have studied the 3 modules. Okay, the same here the will be studying the parallel computing is it's the advanced version of the CO itself. Okay, here we have the 5 modules. Okay, reference book is here, Peter S. Pechoco ಅಂತದ ಒಂದು book ಅದ. Okay, ಇದು ಈ book you have to refer this one. Okay, this is the best book. Okay, Pechoco. Okay, Matthew Maxlens. This is the an introduction to parallel programming. Okay, parallel programming, it's okay. Okay, this is second edition. Okay, even you need the one more book is there, parallel programming with the C with, okay, parallel. This is the uh, first book, this is the second textbook here, Michael J. Quinn. Okay, Michael J. Quinn. Okay, here we have the parallel programming in the C with the parallel programming in C. Okay, in C with the MIP, MPS with MPS, and also we have the Open MD. Okay, this is the book. Okay, these 2 books are I'm referring here. Okay, these 2 books are already available in the library. Okay, just you go and collect it. Okay, okay, these 2 books are very important. Okay, this parallel programming will see with the MIPS. Okay, for and also OpenMD. This is the main book for the your integrated lab. Okay, I will be referring this book for your integrated lab. Okay, okay. First we'll go through the parallel computing. Here also we have the same as the 50 marks for the 50 marks for the theory, and also 50 marks from the integrated lab. Okay, integrated lab also we have the for this integrated lab also. Okay, similarly I'll be taking this integrated lab. Okay, don't worry about this integrated lab. I'll take the after completion of this first module only. Okay, first we'll go with the first module only. Okay, am I audible? ನಾನು ಕೇಳಿಸ್ತಿದೆಯಲ್ಲ ಮಾತಾಡಿದ್ದು? ಹಾಂ, ಯಾಕೆ ಫ್ಯಾನ್ ಹಾಕಿಲ್ಲ, ಕೇಳಿಸ್ತದ? ಫ್ಯಾನ್ ಹಾಕಿದ್ರೆ ಕೇಳಿಸಲ್ಲ. Okay, first foremost, what is the parallel computing? Okay, parallel computing, it is the form of the computation in which the where some calculations are carried out simultaneously. We are doing what here, the parallelism. Okay, we are doing the simultaneously we are solving the some computational equations. Okay, some problems. Okay, this is to be solved with the simultaneously. Okay, if I have the any problem, it is the simultaneous use of the multiple. Okay, it is the simultaneous. Okay, it is the simultaneous use of the multiple functional units of the computer for the to solve a computational equation. So computational multiple functional units of of computer to solve the problem. Okay, any problem. Okay, in the world, any problem which is to be derived, which is to be solved with the simultaneously one another with the help of the multiple functional units. Okay, multiple functional units. Okay, that's nothing but here the I am using the as already we know this all traditional softwares. Okay, usually these are usually written with the help of what a serial computational. All the traditional softwares are usually, if you have the traditional softwares, these traditional softwares are written with the help of the serial computation. Okay, serial computing. Okay, okay, this is nothing but the it is the simultaneous multiple functional rules. Okay, it is the simultaneous, it is a simultaneous use of multiple functional units of the computer's resources to solve the problem, any problem. Okay, if you have the any problem, any equations. Okay, if I have the a plus b, okay, multiply with the c plus d. Okay, this can be solved. Okay, simultaneously as the a plus b one time, and also we can solve with the c plus d at the same time. Okay, I will be dividing this problem into two small chunks as the one unit. Okay, these one units can be solved. Okay, with the simultaneous means parallel we can solve this one. Okay, how this is to be done here, the here. Okay, before going to know the parallel computing, let me explain serial computation. Okay, serial computation. Okay, serial computation is nothing but the problem is broken into a small series of instructions. Okay, ಬರ್ರಿ, don't ask me. Okay, just you come here. ಬರುವಾಗಲೂ ಕೇಳಬೇಡ್ರಿ, ಕ್ಲಾಸ್ನಿಂದ ಹೊರಗೆ ಹೋಗೋನು ಕೇಳಬೇಡ್ರಿ. ಓಕೆ, ಇಟ್ಸ್ ಯುವರ್ ಚಾಯ್ಸ್. ನಾನು ಫುಲ್ ಫ್ರೀಡಮ್ ಆಗಿರ್ತೀನಿ. Okay, serial computing is nothing but the problem is divided into a number of instructions, which are serial number of instructions. These are executed on sequentially, one by one. Okay, okay. The problem is broken into series of instructions. Series of instructions executed, which are all executed with the help of executed in sequentially, one after another. Okay, it's nothing but the problem is broken into series of instructions. These instructions can be executed one by one. Okay, before execution of the first instruction, it will not execute the second instruction. It will take the one by one, serially it will take one, okay. It will execute the each and every instructions of the problem one by one, okay. Serially it is taking out sequentially, okay. By this one we have the, as if I have the problem is a, okay, this problem, okay, this problem is divided, okay, with the series of instructions, so many instructions, okay, okay, so many instructions which are executed on the single processor, okay, which are executed on the single processor. Here the main instructions are there: instruction 1, instruction 2, instruction 3, okay. This problem is divided into number of sequence series of instructions, okay, series of instructions. These instructions can be executed only on the single processor, which are executed sequentially, okay. I can't execute the third instruction until the execution of the first instruction. It has to wait for the execution of the third instruction. This third instruction has to, for the execution, it has to be perform the execution of the first and second sequentially. It has to be take. This is nothing but here the consuming the more time here, consuming the more time, and also it's a drawback, okay. We have the drawback here, okay. More time here, and also here the cost effect is also more, cost is more here, and also it's not providing the concurrency, okay. We need every day, nowadays each and every field need the concurrency every day, okay. This serial computation, it will not give the computing, it's not giving the not giving the what is not giving concurrency, okay, concurrency, okay. This is the main drawback here. To overcome this problem of serial computing, we go through with the parallel computing, okay. What is this we are studying here? Parallel computing is nothing but the it's a simultaneous use of the multiple functional units to on a computer to solve the problem at a time. We are using the some functional units as the ALU, arithmetical logical unit is there, okay. This can solve the what here the arithmetic operations and even logical operations, but it will not solve the floating floating some instructions are there, some other instructions are there. It will not solve, okay. It will not execute it on the ALU. Thereafter it has to be take the another functional unit, okay. Simultaneously it is taking, okay, one by one, okay, okay. That's nothing but they are the parallel computing, okay. Let me explain one more thing, one more example. Okay, as you already know this one, okay. Let me take the same problem here, okay. Same problem here, same problem here, okay. This problem is divided into number of small pieces of problem. This we call as the sub problems, okay. Sub problem, okay. Sub problem 1, sub problem 2, like this we have the, we will be dividing this main problem into sub problems, means small chunks. This sub problem is again is divided into given into number of instructions, number of instructions which will be executed on the CP1, okay. CPU, I'm not taking the CPU1 means what, separate processor here, separate processor. It's nothing but the CPU is nothing but the sum of the functional units, okay. Instead of using the taking the sub CPU, okay, I'll be taking this here functional units, some functional units like arithmetical logical units. I'll be saying this one, okay. Okay, next is here. This second sub problem is also divided into small number of instructions. This can be executed on the second CPU, and also this third is also divided into number of instructions. This can be executed on the third CPU, okay. Third CPU is nothing but here the functional units, okay. Don't take this as separate processor itself, okay. On a single, okay, here we will be using the single processor I am using, which can be executed one by one sequentially on a single processor. But here the same problem I am taken here, but the same problem is taken, and this same problem is divided into small sub programs, some sub problems, okay. These sub problems are divided again divided into small chunks, means what is some instruction 1, instruction 2, instruction 3. These can be executed on the CPU, okay. Okay, for the solution, okay, for solving the these three sub problems are solved at the same time. Here the at the same time these are not, it will not wait for the third sub problem is not wait, will not wait for this first problem. Okay, first sub problem. Okay, these sub problems are solved at the same time in on a single single unit and with the different units with the at the same time. It means here we are doing the solving the sub same problem parallelly. Parallelly means what? We are solving this problem with the parallelly. Okay, parallelly. Okay, this is nothing but here the this is nothing but here the we have the, okay, this is the parallel programming. Okay, for example, if I take the in the serial computing, okay, serial computing, I have taken the some example as the a plus b. A plus b is the multiply of the c plus d. Okay, this is the some expression, this is some problem here I have it. Okay, I will be taking this as the addition, this is also addition. Okay, this for this purpose I am taking the this one is solved with the uh, sub problem 1 and also after completion of only this one is to be executed in the arithmetical logical unit. Okay, arithmetical logical unit. Okay, this is to be done on the cpu1, this is to be done on the cpu2. Okay, after the completion of these two it is giving the answer. Okay, it is giving the some solution for this one. But here the same problem if I consider here example, if I consider here a plus b and also C plus D. C plus D. Okay. Here the same problem is to be executed on the first time and also second time. Second. But here the if it is a arithmetical unit, okay, this is the arithmetical. If it is a some other logical operations, this to be executed on the CPU1 and also CPU2 simultaneously execution at the same time it's starting. But here the until the completion of the a plus b solving, it has to wait for this one c plus d. C plus d, if you want to execute the c plus d, it has to wait until the execution of the a plus b. It is we are waiting, we are waiting serially. It is after the execution of the first, second, third it will be taking. But here the parallel computing, here the at the same time only we can execute it. Okay, a plus b also solved at the same time and also c plus d also solved, and at the end it is giving the answer fast. It is the fast means parallel computing is the main advantage here the solve the time. Okay, it's the saves the time, it's the save the time. ಇದು ಏನು ಮಾಡ್ತಿದೆ, it is saving the time and also it's giving what here the solve the larger problem, solve the larger problem. If I have the larger problem with the, I can't solve with the serial computing, it will take more time. But here the I can solve this larger problems with the help of the parallel computing. Okay, and also its cost is cost is less. How the cost is less? Cost is depends on the time only. It's consume less time is what? Cost will be also less, and also it provides the concurrency. Provides the concurrency. Concurrency, and also use the, it will not use the local machines. It will be using the faster for faster purpose. Okay, take it. Write down it. Parallel computing. It is a simultaneous use of the it is a simultaneous use of the multiple computer resources. ಗೊತ್ತಾಯ್ತಾ? Parallel computing ಏನಾಗುತ್ತೆ, some main problem is divided into sub problems. These sub problems are executed simultaneously. Okay, simultaneously, so that it will not take the more time here. It's we are saving our time. Okay, with the different processor we are using. Here processor means what? Here if I am now taking the, if any instruction, okay, some any problem, okay, problems are written with the help of what? Solved with what? Programs only. Programs are usually written in the C program with the help of what? Instructions. Okay, these instructions has to be executed. Okay, executed. But if I have the a plus b multiplication arithmetic operation, next in the same equation, the same problem only, if I add the any logical operation for the until execution of the arithmetic operation, logical operation will not execute in the serial computation. First, if I go for the parallel computation, they're computing, there I can solve the same arithmetic operation, logical operations, even floating operations are there. This can be solved at the same time. First, it will give the answer. At the time, it will gather the some answers, whatever I need, the solution for that one. It will give the, at the end, faster it will not. It will not consume that more time. So that parallel computing usually used in the everywhere in nowadays, okay, in the AA, Google search, everywhere, okay, even chemistry, even mathematics, and also even electrical engineering, computer science engineering, in the each and every field, okay, in the weapons also they are using in the many field, okay. Nowadays in all whatever we are using the CPU, what are the systems, okay, processors and all, these are all what here we are using the concept of the parallel computing. Parallel computing is not a new subject here, new concept here. Parallel computing is already existed, okay, it's already exist, okay. In the 1950 only it is they have started in the giving the solution for this one with the parallelly with the how to solve the problems with the parallelly, okay. Parallel means they need some solution for the faster execution purpose, okay. This is not a new subject, this is not a new concept, it's already working over on that, okay. We are already using the parallel computing each and every field, okay, as chemistry field, mathematics, even computer science engineering, electrical engineering, not a field, okay. I'm telling you here not a branch, in each and every field, okay, even weapons, even everywhere, okay. Everywhere we are using, okay. In the biochemistry, biotechnology also we are using atmosphere, each and everywhere we are using the parallel computing, okay. This is not a new concept, this is not a new subject here, okay. You should remember this is the advanced version of the siva ದಾಗ ಏನು ಓದಿರ್ತಿರಲ್ಲ, this is the extension version of the CO only, okay. The parallel computing is the nothing but the here the CO, whatever you studied in the third semester, no, DDCO, digital design and computer organization, there you have studied the three modules, okay, three modules. The same three modules is here also, but here the advanced version ಅಷ್ಟೇ, ಮತ್ತೊಂದೇನಿಲ್ಲ, ಏನು ಹೊಸ ಸಬ್ಜೆಕ್ಟ್ ಇಲ್ಲ, ಹೊಸ ಕಾನ್ಸೆಪ್ಟ್ ಇಲ್ಲ, okay. Take the heading as the parallel computing. I will give the some notes, okay. For that purpose I need to suspend 1.5 hour. ಅದು ಹೇಳೋಕ್ಕಾಗಲ್ಲ ಟೈಮಲ್ಲಿ, ಸ್ವಲ್ಪ ಸ್ಮಾಲ್ ನೋಟ್ಸ್ ಕೊಡ್ತೀನಿ. ಇಟ್ ಇಸ್ ದಿ ಸೈಮಲ್ಟೇನಿಯಸ್ ಯೂಸ್ ಆಫ್ ದಿ ಮಲ್ಟಿಪಲ್ ಕಂಪ್ಯೂಟರ್ ರಿಸೋರ್ಸಸ್. ಎವ್ರಿ ಡೇ ಕೊಡಲ್ಲ ನೋಟ್ಸು, ನನಗೇನೋ ಫೀಲ್ ಆದ್ರೆ ಕೊಡ್ತೀನಿ ಆಲ್ರೆಡಿ, ಯಾಕಂದರೆ ನೀವು ಆಲ್ರೆಡಿ ಯು ಆರ್ ಇನ್ ದ 7th semester, ಯು ಡೋಂಟ್ ನೀಡ್, ಓಕೆ, ದೀಸ್ ಆರ್ ಆಲ್ ಐ ನೋ. Sometime I need to spend time, okay. It is the simultaneous use of the multiple computer resources. It is the simultaneous use of multiple computer resources to solve a computational problem. Here the computer resources are nothing but the different functional units. What are the units? You have the computer, okay, you know, on the processor itself you have the different units, okay, as the ALU is there, arithmetic logical unit is there, multiplier MU is there, and also so many units are there, okay. Now some registers are there, so many are there, okay. You studied in the microcontroller, you have studied the so many some architecture of the processor you have studied, microprocessor you studied, microcontroller you have studied, no. In the processor itself you have the so many units, okay. Functional units are nothing but in the processor itself you have the different units, okay. All traditional softwares has been written for serial computation. Next point, all traditional software has been written for serial computation. Next point, serial computer. Next point ತೋರಿ, serial computer ಅಂತ ಬರ್ಕೊಂಡು serial computing ಅಂತ ಬರ್ಕೋರಿ, okay. A problem is broken into series of instructions. A problem is broken into series of instructions, executes sequentially, okay, A problem is broken into multiple instructions. These can be executed sequentially on a single processor, on a single processor, on a single processor. Just to write down this one, okay? This copy this figure. Just to copy that figure, okay? A problem, okay? This problem, okay? The same problem can be taken, explained with the parallel computing also. Okay, just to copy. I hope you all copied, no? Okay. Next point. Just to copy this figure also, okay? Okay, this you write the parallel computing, you just to write the parallel computing. And also problem, okay? This problem is divided into sub problems or subunits. This subunits again is solved with the number of instructions. These number of instructions are separate, executed on separate process, separate CPU, CPU1, CPU2, CPU3. Okay, this here will not wait for the for solving the sub problem of the one. For solving the sub problem of third, it will not third will not wait for the one. Okay, it's these three sub problems are to be solved simultaneously. So thereby we can save the time, and also we can cost effective also less. Okay, just to copy this one. Okay, what is the necessity of having the parallel computing is nothing but this, just to take the why and what, to save the time, solve the larger program, larger problem, cost is less, and also provide the concurrency, take those 4 points also. I hope you all copied this one. Okay, shall I raise this one? Huh? Okay, usually parallelism will be seen, okay, in the hardware. Okay, parallelisms can be seen in the hardware. Okay, okay, parallelism usually not seen in the software. Okay, we have to assume that, okay, we are what we are writing the programmatic and all will not see, okay, whether we are executing the same parallelism or not. Okay, we can achieve this parallelism with the in the we can see the parallelism in the hardware. Okay, the parallelism in the hardware. Okay, usually parallelism is to be done with the help of the pipeline. Okay, pipeline operation, you know this one. Okay, execution of the pipeline. Okay, pipeline is nothing but in the first cycle we can execute the fetch, next decode and execute. Okay, in the first one. Okay, next we can the same period of time we can fetch, and also even we can also decode that one, and also we can execute that. It's nothing but pipeline is nothing but the here we are achieving what here parallelism. Here also we are doing what here parallelism. Pipelines internally it provides what a parallelism. Okay, parallelism. Okay, who is using the parallel computing mainly with some all over the world. Okay, globally we are using the parallelism. Okay, globally we are using the parallel computing. Okay, this means we are here the everywhere in the biotechnology we are using, in the medical field also we are using, and also atmospheric environment also, and also you are using the mechanical engineering, and also electrical engineering, computer science engineering also we are using, and also mainly we are using nowadays the in the big data subject, there also we are using the parallelism, and also in the AI. artificial intelligence also. Already we are using parallel computing. That one only we are studying how the that parallelism is working in each and every field of computer subjects, how they are using, okay, in this parallel computing. Mainly my subject here is to concentrate to the explain the parallel computing, how the each and everywhere, okay, in the every field we are using the parallel computing, okay. That's the main here in the how the parallel computing is used. They are using nowadays parallel computing in each and every field, no, how they are using the my parallel computing will be studying, okay, each and every time, okay, in bit wise, okay. Globally where the application is the parallel computing is not is nowadays in the basic, okay. This becomes what a basic, okay. This basic becomes a basic ಆಗ್ಬಿಟ್ಟೈತಿ ಎಲ್ಲ ಕಡೆ parallelism, okay. Classification of the parallel computing, okay. As you already knew this one, our main computer is based on what here, the Van Neumann architecture ಬೇರೆ architecture ಮೇಲಿದೆ. Our main, okay, our main computer nowadays whatever using, no, this is all what your is it based on the Van Neumann architecture or some other one? Van Neumann architecture only, okay. You should have to remember this one. Whatever you are using the some architecture, no, for nowadays normally we are using everywhere in the computers. These computers were based on what Van Neumann architecture only, okay. In the 1945, okay, Neumann. Okay, we can evaluate, okay, even evolution of the computer is based on the from the Van Neumann architecture only. In the Van Neumann architecture we are using the control unit and the ALU on a same processor only, same unit only. That's the main here. And also we this is the Van Neumann architecture is started on the 1945 only, 1945 only, 1945 the years given. And also it is also known as the stored program stored program computer, okay. As you already know this one, stored program computer, because Van Neumann architecture we are using the earlier days before the Van Neumann architecture, there we are using the hard wiring there for computation between the, okay, for the computation between the CPU and this is the arithmetic logical unit and some other operations, whatever the units have, you have the memory, some water, okay. This for the hardware, okay. For the arithmetic logical unit, for the operations of arithmetic logical operations, there we are using the hard wiring use ಮಾಡ್ತಿದ್ವಿ, hard wiring. In the system only, in the computer itself we are using the hard wiring use ಮಾಡಿ ಆ ಥರ ದೊಡ್ಡ ದೊಡ್ಡ ಮಷಿನ್ಗಳು ಹಿಂಗೆ ಹೇಳೋದು ಮಾಡ್ತಿದ್ರು ಈ ಥರ ಬಿಫೋರ್. After the Van Neumann architecture, the evolution of the computers are based on the Van Neumann architecture only. When the Van Neumann invented the some operations of the computer as the arithmetical logical unit, sorry, control unit and also ALU on a single ಪ್ರೊಸೆಸರ್ ಬಲ್ಲಿ ತೊಗೊಂಡು ಬಂದವನು ಮೊದಲ ಬಿಫೋರ್ ಇದ್ದಿದ್ದಿಲ್ಲ, ಇದು ಬೇರೆ ಬೇರೆ ಕಡೆಗೆ ಇರ್ತಿದ್ವು, ಸಿ ಪಿ ಅಲ್ಲಿ ಇರ್ತಿದ್ವು, ಓಕೆ. ಆ್ಯಂಡ್ ಆಲ್ಸೋ ವಿ ಹ್ಯಾವ್ ಟೇಕನ್ ದ memory. This is the main basic computer architecture is this one. And also we have the input, this is what output, okay. This is the main architecture of the Van Neumann, okay. Okay, based on this, okay, based on this computer only we have the different types of parallel computing here, different types of parallel computing. This is the main based on this concept only. Based on this Van Neumann architecture only, I will be deriving the some different types of parallel computing. Okay, you should have to remember. Okay, based on this uh, Van Neumann architecture only, I will be deriving the some other types of computing computer architecture which is for the parallel computing purpose. Okay, parallel computing purpose. And here we have the different types of parallel computing are there based on the Flynn's taxonomy. Okay, Flynn's taxonomy. Okay, in the 1966 only, this subject is in started studying. Okay, this is not a new subject. You should remember. Okay, it's not a new subject for you. It's already done. It's already studied it. Okay, but here the some easy subject. This is what one of the easiest subject in for your seventh semester. Just to concentrate on the figures and also some piece of codes are there everywhere. Small piece of code, for loop, some execution of some if else, some small piece of C program is there. Just that's nothing. Okay. Okay. Shall I raise this one? Based on this traditional Van Neumann architecture only, I can derive the different types of the parallel computing architectures. Here we have the in the 1966 only, in the 1966 only this parallel computing derived. Okay, different ways of parallel computers are there widely used. Okay, based on this one with the instruction stream and data stream. Okay, instruction stream, this is the instruction stream and also data stream. Based on these two concepts, okay, based on these two points, we can derive the parallel computing. Okay, we can derive the parallel computing as the single and multiple SI, MD, SI, SISD, and also SIMD, MIMD, sorry, SIMD, and also MIMD. Okay, what is SISD, SIMD? Yes, is nothing but the single instruction, huh? Single instruction stream, single data stream. Single instruction, single data stream, single instruction, multiple data stream, single instruction stream, multiple data stream, multiple instruction stream, multiple data stream. Okay, like this we have the different types. Here we will be studying the these four only separately. Okay, separate. It will they will ask for this one separate for the 10 marks, 10 marks, 10 marks for your examination. Just to okay, this parallel computing can be classified. Okay, classification of the, just to write the classification of the parallel computing. Okay, how the parallel computing is classified? We on the in the 1966 one they classified based on what are the instruction stream and also data stream. Okay, around we have the four types of parallel computing here. One is what a single instruction stream, single data stream. Wherever you'll find the single, just to remember, wherever you find the I, just to take it as the instruction. Wherever you'll find this one D as the data, M as the multiple, just to remember this much. Okay, just to make it say some what some operations as the some made it as some computations. Okay, segregate it. S is the single instruction, single instruction stream, single data stream, single instruction stream, multiple data stream, single instruction stream, multiple data stream. Same ಬರ್ದಿನಲ್ಲ ಹಾಂ ಸೇಮ್ ಬರ್ದಿನಲ್ಲ ಇದೇನಾಗಬೇಕು ಎಮ್ ಐ ಎಸ್ ಟಿ ಆಗ್ಬೇಕಿದು ಸಾರಿ ಎಮ್ ಐ ಎಸ್ ಟಿ ಓಕೆ ಮಲ್ಟಿ ಸಾರಿ ಮಲ್ಟಿಪಲ್ ಮಲ್ಟಿಪಲ್ ಇನ್ಸ್ಟ್ರಕ್ಷನ್ ಮಲ್ಟಿಪಲ್ ಸಿಂಗಲ್ ಸಾರಿ ಹೇಳ್ಬೇಕಲ್ಲ ಓಕೆ ಮಲ್ಟಿಪಲ್ ಇನ್ಸ್ಟ್ರಕ್ಷನ್ ಸಿಂಗಲ್ ಡೇಟಾ ಸ್ಟ್ರೀಮ್ ಮಲ್ಟಿಪಲ್ ಇನ್ಸ್ಟ್ರಕ್ಷನ್ ಮಲ್ಟಿಪಲ್ ಡೇಟಾ ಕನ್ಫ್ಯೂಸ್ ಆಗುತ್ತಾ ಬರೀ ಓಕೆ ಜಸ್ಟ್ ಟು ಟೇಕ್ ದಿಸ್ ಒನ್ Based on this only, we can classify this one as the 4 types: SI, SD. This one is the SI, MD. ಎರಡು ಸಲ SI ಬರ್ರಿ, SD MD ಬರ್ರಿ. ಆಮೇಲೆ MI, SI ಯಾವ್ದು? SI, MD, MI, MD. ಇದು ಕೆಳಗೆ ಬರ್ರಿ. ಸಿಂಗಲ್ ಇನ್ಸ್ಟ್ರಕ್ಷನ್ ಸ್ಟ್ರೀಮ್ ಈ ಥರ ಬರ್ರಿ. ಸಿಂಗಲ್ ಇನ್ಸ್ಟ್ರಕ್ಷನ್ ಸ್ಟ್ರೀಮ್ ಮತ್ತು ಸಿಂಗಲ್ ಡೇಟಾ ಸ್ಟ್ರೀಮ್ ಅಂತ ಬರ್ರಿ. ಸ್ಟ್ರೀಮ್ ಅಂತ ಬರಿಬೇಕಾ? You should not write the stream, okay, everywhere. Single instruction stream, single data stream. Single instruction stream, multiple data stream. Single instruction stream, multiple. Hi. Yeah, MIST. Okay, multiple instruction stream, multiple data stream, multiple instruction stream. Hey, MISD na. Hey, confuse ಆಗ್ತಿದಪ್ಪ. MISD, MIMD. Okay. ಆಗುತ್ತೆ. Okay, this is the, okay, usually this is we called as the Flynn's. Okay, this we called as the, this is we called as the, what we call Flynn's taxonomy. Flynn's okay, Flynn's taxonomy. Okay, this classification what we call as the Flynn's. Flynn's based on the Flynn's taxonomy. In the Flynn's taxonomy, this is based on the 2 type. Okay, instruction stream, data stream. Okay, based on the Flynn's taxonomy, we can classify the parallel computing as the based on the instruction stream, data stream as the SISD, SIMD, MISD, MIMD. Okay, 4 types. ಈಸಿ ಅದ ಸಬ್ಜೆಕ್ಟ್, ಸ್ವಲ್ಪ ಥೆರಿಟಿಕಲ್ ಇರ್ತದೆ, ಸ್ವಲ್ಪ ಸ್ಲೋ ಆಗಿ ಹೋಗೋಣ. ದಿಸ್ ಒನ್ ಆಫ್ ದಿ ಈಸಿಯೆಸ್ಟ್ ಸಬ್ಜೆಕ್ಟ್. ಫ್ಯಾನ್ ಆನ್ ಮಾಡ್ತೀರಿ? ಮಾಡಂದ್ರಿ? ಯಾವ್ದು ಮಾಡದ್ರಿ? ಇದ್ರಿ ಹೊಸು ಇರಾವ ಎರಡವ ಬರಲಿಲ್ಲ. ಅಯ್ಯಪ್ಪ, ಇದೇ ಸೌಂಡ್ ಬರ್ತದೆ. ಅದೊಂದು ಇರಲಿ, ಎಲ್ಲರಿಗೂ ಬರುತ್ತೆ ಗಾಳಿ, ನನಗೇನು ಬೇಕಾಗಿಲ್ಲ ಗಾಳಿ, ಯಾಕಂದ್ರೆ ನಾನು ಸೌಂಡ್ ಬರಲಿಲ್ಲ ನಮಗೆ. ಅವ್ರಿಗೆ ಗಾಳಿ ಆಗ್ತದ, ಚಳಿ ಆಗ್ತದೆ, ಆ ಕಡೆ ಬೇಕಾ? ಅದು ಸ್ಟಾರ್ಟ್ ಆಗಲ್ಲ ಅಂತ. ಅವ್ರಿಗೆ ಬೇಕಾಗಿಲ್ಲ ಪಾಪ ಗಾಳಿ. ಅದು ಬಂದಾಗಿದೆ ಫ್ಯಾನು. ಹಾಂ, ಈ ಬಾರೋ ಇಲ್ಲಿ. ನೀನೇದು ಬಾ, ನಂದೇ ಇರಲಿ ತಗೋ, ನಂದೇ ಇರಲಿ. Okay, first one we consider the SISD. Okay, first one is, okay, we'll consider the SIMD. For this syllabus we have the SIMD and also MISD. For your syllabus we have the SIMD, SIMD and MIMD. For your syllabus we have the SIMD and also MIMD only. We'll be studying these 2 architectures. First we'll take consider the SIMD. SIMD is nothing but the single instruction multiple data stream. Work करो. Easy the book. Subject is so score ಆತ ನೋಡಿ ಬರೀ ಅಷ್ಟೇ ಥಿಯರಿ ಅದ ಸ್ವಲ್ಪ ಕೋಡ್ ಅದ ಈ ಥರ ಎಲ್ಲ ಕಡೆ ಎಲ್ಲ ಬುಕ್ ಎಲ್ಲ ಮಾಡಿಲ್ದಾಗ ಅಷ್ಟೇ ಸಿ ಪ್ರೋಗ್ರಾಮ್ ಬರ್ಬೇಕು ಸ್ವಲ್ಪ ಬೇಸಿಕ್ ಹೆಂಗಿದ್ರೆ ಕಲ್ತಿರ್ತಿರಲ್ಲ ಏನು ತಿಳಿ ಕಳಿಸ್ಬಿಟ್ರು ಓದ್ರೆ ಹೋಗಿ ನಾನು ಹೇಳ್ತೀನಿ ಅಲ್ಲಿ ಕಂಪ್ಲೀಟ್ ಅರೌಂಡ್ 4 ಮಾಡ್ಯೂಲ್ಸರ್ಗೆ ಹೋಗಿ ಹೇಳ್ತೀನಿ 4.5 ಮಾಡ್ಯೂಲ್ಸ್ ಬಿಡಲ್ಲ ನೀವು ರೆಗ್ಯುಲರಾಗಿ ಬಂದ್ರೆ ನಾನು ಬಿಡಲ್ಲ ನೀವು ಬರಲ್ಲ ಅನ್ಸುತ್ತೆ ಹಾಂ ಬರ್ತೀರಾ ಯಾರಾದ್ರೂ ಕಂಪ್ನಿಗೆ ಹೋಗ್ತಿದ್ರೆ ಹೇಳ್ರಿ ಸುಮ್ಮನೆ ಇಲ್ಲಿ ಹೇಳ್ಬಾರ್ದು ಕಾಲೇಜ್ನಾಗ ಒಂದು 15 ದಿನ 20 ದಿನ ರಿಯಲ್ ಟೈಮ್ ಕೋಡಿಂಗ್ ಕಲಿಯೋದಿತ್ತು ಅಂದ್ರೆ ರಿಯಲ್ ಟೈಮ್ ವರ್ಕಿಂಗ್ ಎನ್ವೈರ್ಮೆಂಟ್ ಹೆಂಗಿತ್ತು ಅಂತ ಕಲಿಯೋದಿತ್ತಂದ್ರೆ ನನಗೆ ಅಪ್ರೋಚ್ ಆದರೆ ನಾನು ಕಳಿಸ್ತೀನಿ ಇಲ್ಲಿ ನಮ್ಮ ಗುಲ್ಬರ್ದಾಗವ ಕಂಪ್ನಿಗಳು ಸಣ್ಣ ನಿಮಗೇನು ಎಲ್ಲಿಯಾದರೂ ಸೇಮ್ ವರ್ಕಿಂಗ್ ಎನ್ವೈರ್ಮೆಂಟ್ ಇರ್ತದೆ ಬೆಂಗಳೂರಾದ್ರೇನು ಮಂಗಳೂರಾದ್ರೇನು ಸೇಮ್ ಕಂಪ್ನಿ ಇರ್ತದೆ ವರ್ಕಿಂಗ್ ಎನ್ವೈರ್ಮೆಂಟ್ ಸೇಮ್ ಇರುತ್ತೆ ಅವರೆಲ್ಲ ವರ್ಕ್ ಎಕ್ಸ್ಪೀರಿಯನ್ಸ್ 10-15 ವರ್ಷ ವರ್ಕ್ ಮಾಡಿ ಬೆಂಗಳೂರಾಗೆಲ್ಲ ವರ್ಕ್ ಮಾಡಿ ಇಲ್ಲಿ ಕಂಪ್ನಿ ತೆಗೆದ್ರೆ ಸೇಮ್ ಅವ್ರದ್ದೇ ಪ್ರಾಜೆಕ್ಟ್ ಇಲ್ಲಿ ವರ್ಕ್ ಮಾಡ್ತಾರೆ ಯಾರಾದ್ರೆ ಬೇಕಾದ್ರೆ ಸುಮ್ಮನೆ ಕಲಿಯೋದು ಕ್ಯೂರಿಯಾಸಿಟಿ ಇತ್ತು ಹೆಂಗೆ ಇತ್ತು ಅಂತ ಕಲಿಯೋದು ಬರ್ರಿ ಅದೇನು ಇರೋಲ್ಲ ಫ್ರೀ ಆಫ್ ಕಾಸ್ಟ್ ಇರುತ್ತೆ ಏನು ಕೇಳಮ್ಮ ನಮ್ಮ ಫ್ರೆಂಡ್ಸ್ ಅದು ಕಳ್ಸಂತಂದಾರ ಅವರು ಕಾಲೇಜ್ನಾಗ ಬಿಡಲ್ಲಲ್ಲ ಅವರು ಈಗ ಮೇನ್ ಕ್ಲಾಸ್ ಹಿಡ್ದವ ನೋಡೋಣ ಓಕೆ SIMD is nothing but the single instruction multiple data. Single instruction multiple data parallel system. Okay, these are the systems. Okay, this is also one of the system. Okay, SIMD is the single instruction multiple data system. It is using the parallelism here. As the name suggests here, the SIMD is using the only single instruction to stream to work on the multiple data. It's multiple data. Here the single instruction is controlling the multiple data. Single instruction itself controlling executing the multiple data. It's using the multiple data here. And also here mainly you are using the control. Here the controlling unit is only what a single unit is there. It's controlling the multiple data. It's controlling the multiple data. As the name itself suggests that the SIMD itself suggests that the single instruction itself handling what a multiple data. You should remember single instruction itself handling the multiple data. Okay, if you want to carry out the some operations here, the some operations as vector addition is there, floating point operations are there, so many operations are there. This to be carried out in the system with the help of what SIMD only. If I want to check, okay, if you want to if I want to carry out the some operations as the parallelism, okay, some with the help of vector addition, we can see the vector addition. For example, here I am sending the some elements. Okay, for loop I am using here for I equals to 0, I is less than n, and also I plus plus. Okay, I plus plus. Okay, here I want to transfer some data. Okay, some 2 arrays are there. Let me consider 2 arrays are there. X of I is one array, and also Y of I is another array. Okay, I want to transfer. I want to carry the some data. I want to transfer, move the some data from the Y to X. How it has to be done? With the help of what here, the X of I with the operations as the plus of equal to Y of I. Here the some array. Okay, Y of I is also having the some array of number of elements in the array. Okay, X is the one of the array. It is also having the some more elements here, some more elements here. The I want to move, I want to add the some elements from the y array to x array, y array to x array. How it is to be done? It is to be done with the some operations are here, the plus and equal, that's nothing but the addition equal to this. This is the to be done. Okay, this is nothing but we are whatever we are explaining. This is to be carried out with the help of what here, the single instruction multiple data. Single instruction multiple data. It's moving one from the elements, from the array elements y array to y array of some elements in the y is to be moved to where in the x. This is the main concept here. How it is to be done with the, this one is the this operation. This is to be done with the help of what, vector addition. This we call as the vector addition. This we call as the vector addition. We are adding the some elements from the y array to x array. This to be done with the parallelism, done with the single instruction multiple data only. How it is to be done? Let me explain with the example here. Okay, ಅದು ನೆನ್ಪಿಟ್ಕೋಬೇಕು Flynn's taxonomy. Okay, this parallelism is parallel computing is divided into four. Okay, SIMD, SISD, and MISD, MIMD. This is based on what? Flynn's taxonomy. Okay, Flynn's taxonomy. You should remember this word. Okay, it is to be very important. They will ask for the Flynn's taxonomy. Explain Flynn's taxonomy. You should have to explain this one. Okay, I am explaining here what the SIMD system is having the n number of data pass. Here the higher the n number of data pass, here the n number of data pass, here the this to be n number of data to be carried. Okay, move to where in the from the y elements to the array of the 5 elements to the array to the x only, in the x only. This is to be done with the help of what, for loop. This is to be with the help of the for loop. So that I already told you that I need here some basic C programming knowledge. That's it. Okay, in the each and every time. Okay, here the first in the first stream. Okay, for example, if I take this one as the m is, okay, for example, m a number of elements here. I will take the m and the n are the two elements here. The m is the nothing but the how the piece of codes. Okay, what the number? Okay, it's if I taken the 5, n as the elements as the 15. If I will be taking this m as the number of elements. Okay, 0 to 10, 0 to 3. These are the 4 elements has to be moved at a time to the next element. Okay, and also 4 to 7, yes, sir, to the second unit, and also 8 to 12 in the third unit, and 12 to 13, 8, 9, 11, 12, 8, 9, 10, 11, okay, 11, okay, 12 to 15, okay, in the fourth. Okay, okay, these to be carried. Okay, with the help of the difference of the 4 4 here, the chunk of the 4 4. Okay, if I take the elements as the 15, okay, 15 has to be transferred from the from array of the y to the x. Okay, I'll be taking with the this 15 has to be divided into what here, the 4. Okay, four chunks. For every time I'll be sending the elements of having what here, the 4 chunks in the piece of the 4 4, 0 to 3 1 first time, 4 to 7 second time, 8 to 11 third time, and say 12 to 15 as the fourth time. This is the wrong here. In the fourth time we are sending what here, the only 3 elements there. Okay, 12 30, how much, 12 13 14 15. Okay, we are sending the, okay, sorry, 15 ಅಲ್ಲ 15 ಆಗಬೇಕಲ್ವಾ, 0 ಕಳಿಸಿದ್ದೀನಿ ನಾನು 14. Okay, here sending only I am sending here the only 3 elements here. I am sending here 3 elements here. This is the main drawback here. So one of the 4 pass will be ideal here. Okay, this for this 4 pass purpose, these 3 has to be ideal. Okay, this is the somewhat different. Okay, for this purpose we have the single instruction multiple data. We are sending the all are sending with the single instruction. What is the instruction here? I have to send the 4 elements every time. 4 elements every time. I am sending how many data here? 4 data at a time. This is what multiply. I am parallel. I am sending the multiple data here with the single instruction. What is the instruction here? The instruction is here the you have to send the elements which is having the round of what, how much, 4 only. This instruction it has to follow every time for sending the parallelly. Okay, for this one 0 to 3 first time, second, third. Okay, these two four elements, this the four elements has to be sent. Okay, every time for the parallelly. Okay, with the single instruction is what here the m is. Yes, m is 4. In the elements, m in the 15 elements, you can send the 4 at a time. It's a 4 you have to send the 4 at a time means what? This is the single instruction. You need to send the elements having the size of what? 4 only. This is the first instruction, single instruction. With the single instruction, it has to be sent all the elements parallelly, taka 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 taka. Okay, okay. This is nothing but the parallel. It is sending. It's multiple data. It is sending with the help of single instruction. Okay, this is what is the SIMD. And also we can also use the same requirement data paths in the to generate the SIMD also for only the to carry out the addition of the if only positive elements. If I have the negative elements, okay, if I have the negative elements ಇದ್ದಾಗ ಕಳಿಸ್ಬೋದು ಇದರಲ್ಲಿ ಯಾವುದು SIMD ಅಲ್ಲಿ. But if I made it as what, less than I, n is can be anything here. N can be anything here, positive or negative. If I particularize, if I mentioning here only positive elements, that time I'll be sending the in different. Okay, I'll be sending the different as the, instead of using this type of condition, I'll be using the if y of I. Okay, there only you don't write it. You take the another example. Okay, y of I is less than the 0.0 is greater than, it should be greater than the 0, it should be greater than the 0, it should be greater than the 0, and also it should be carried. Okay, and also it has to be transferred. The same thing you need to write here, x of I plus or equal to y of I. Okay, earlier I made the condition only the elements has to be transferred from the elements of the y of array to the x of array with the help of only what here the whatever the elements, it should be less than the n, sorry, more than the n, ಏನಂತ 0 type, more than I. Okay, here the same condition I am not, I am using the same concept here also, but thing is that with the condition of only positive elements. If yeah, y of I equals to is greater than the 0, then only you send the elements from the y of array to the x of array, y of array to the x of array. This is the condition. This we call as the vector addition. This we call as the vector addition. We are making here the parallelism with the sending the only one condition, means nothing but the single instruction, multiple data. We are sending the multiple data on a single instruction. Okay, I hope you all following this one. Okay, if you are not following me, please ask me there only. Okay, nowadays many of the graphic cards, graphic units are using the SIMD and also what are MIMD also. Okay, mainly graphic cards are there. Okay, graphic user interfaces. Okay, whatever we have the graphic cards are there. No, there we are using the this concept only mainly. Okay. Okay, this today we will end up the class here itself. Okay, tomorrow I will continue. Okay, don't take about tension about the lab integrated. Sir, lab and tell about it. Nandu integrated lab da, I'll take the lab after the 15 days or before the completion of the first module. I need some basic concepts. Okay.